Hello lovely YouTube family, welcome back to Tech Power. In today's video we are going to talk about why we still don't have electric planes. Before we start, hit that red subscribe button so that you never miss out on any of our videos. What could a future with electric planes look like? $25 tickets, quieter airports, or even shorter runways? Companies have been betting on battery-powered planes for this cleaner future, but even though electric planes have been around since the 1970s, they haven't really taken off. So, what's keeping them grounded? In the late 1800s, two French army officers experimented with electricity to propel an airship, but they ran into problems when the battery just couldn't hold enough energy. This would become a recurring problem for the next 100 years. When nickel-cadmium batteries were invented, the first flight with an electric motor took off, but it only lasted less than 15 minutes. Then, in the 1980s, lithium-ion batteries were invented. They could store more power than ever before, leading to planes like the Solar Impulse 2. Starting in 2015, the solar-powered aircraft spent 16 months flying around the world, except it flew at an average speed of 28 to 34 miles per hour. Solar Impulse 2 is part of a movement in recent years to develop alternative energies, especially when people and governments started realizing just how bad flying was for the environment. The aviation industry emitted about 1 billion tons of CO2 in 2019. That's about 2.5% of global emissions. That might not sound like a lot, but it's almost as much as the entire continent of South America emits in a year. We need to make changes to the industry, and electrification is one of the big trends which will hopefully reduce that burden. Electric planes have been on people's mind for a while, but two big problems are keeping electric grounded. First, the technology's not quite ready. When you're trying to get an electric plane off the ground, you want a battery that packs a lot of punch in a little package. But, Carolina Anderson, batteries are not as efficient as gas, and they're probably not going to be for a while. A battery's efficiency or ability to hold power is measured in specific energy. Right now, even the best batteries have a specific energy of only 250 watt-hours per kilogram, but we have to get closer to 800 to really start flying, and that is still nothing compared to jet fuel's specific energy, which has nearly 12,000 watt-hours per kilogram. Think about it like those computers from the 80s. They were huge, but way less powerful than the sleek ones we have today. Right now, batteries are like those 80s computers. They're not as powerful as they need to be, and they're not just big, they're also heavy. So if you want to add more power to a plane, you need to get a bigger battery, and to get that plane airborne despite the weight, you'll need even bigger battery that's more powerful, but that means more weight. And then you'll need an even bigger battery to offset that weight. Oh, you get the point. But even if engineers design a plane around the shortfalls in battery tech, they have to take on the industry's second hurdle, certification. In the US, that means getting permission from the Federal Aviation Administration to test and fly an electric plane. Companies have to prove every inch of their aircraft is safe, passing a series of tests, one of which is to make sure the battery cells won't catch fire. If something goes wrong, you can't stop. You can't pull to the side of the road. There's only one place for that airplane to go. And so the regulatory stringency is much higher. The requirements for reliability, redundancy, and safety are much higher for a good reason. You have no alternate. The FAA amended its rules in 2016 to allow electric propulsion systems in airplanes built for up to 19 passengers. The real problem, though, is that certification, even with these amendments, takes years, so companies have gotten creative. They've started to retrofit old planes to get certified quicker. You're taking out the entire old gas-guzzling emission-creating engine and its fuel system and replacing that space and weight with an electric propulsion system. Retrofitting has happened in phases. The first phase was from Slovenian company Pipistrel. It created the world's first all-electric two-seater plane back in 2007 by putting an electric engine in a glider. Gliders are safe to fly by definition, even without a functioning engine, so we were able to experiment without putting anybody at risk or do harm to anyone. Today, those planes are used for pilot training. The second phase, a hybrid. Los Angeles company Ampere replaced one of the two engines in a 1973 Cessna with an electric one. Ampere hopes to get its new plane, the Electric Eel, certified for commercial flights by 2021. And finally, over in Vancouver, electric motor manufacturer Magni X and Vancouver-based airline Harbour Air flew a retrofitted 62-year-old plane. A 15-minute test flight in December 2019 made it the world's first all-electric commercial plane to fly. It proved that electric could actually take off. The two companies' goal is now to electrify the rest of Harbour Air's fleet of more than 40 seaplanes and have it certified by the end of 2021. So, retrofitting seems perfect. The problem, though, is that it limits you to what the plane structure is already built for. So if the original motor is, say, 1,000 pounds, and then you remove it, then I only have 1,000 pounds to put back in, right? I can't make the total package heavier. Electric motors are smaller and lighter than gas ones, but remember, those batteries are heavy. So you lose range because batteries for the same amount of power are so much heavier than fuel. So while Harbor Air and Magna X figured out the balance of weight in their plane, the range took a hit. Their electric plane can go over 100 miles, a little less than the distance from Seattle to Vancouver, but for electric planes to be successful long-term, they'll have to go farther. Israeli company UNVEILS might have a solution. Instead of retrofitting an old plane, its engineers built a plane from scratch. The 9-seater plane, Alice, was designed around the battery to reduce weight. Omer Bar Yohei, that battery's literally all over the place. It's under the floor, it's in the wings, it's the fuselage in different locations. Alice, in theory, could fly up to 650 miles, roughly a flight from Las Vegas to Denver, but because it was built from the ground up, getting her certified is taking longer. We're very confident that we will be testing the plane in flight in early 2020 and believe that from that point on, the certification process will only take about 2 years. Each electric plane in development is different, but they all have one thing in common: they're going after flights under 500 miles. And while it may not seem like an impressive distance, these short-range electric planes could solve a major problem in travel. In 2018, a little less than half of all air tickets sold globally were for flights under 500 miles. But instead of using small, efficient planes designed for these shorter routes, we often use expensive airliners built to fly thousands of miles. These planes are most efficient if they're able to cruise for a long period of time, but on a flight that's 50 minutes, these planes go up and they come right back down. Currently, a 109-mile flight from Los Angeles to San Diego emits about 110 pounds of CO2. For a technical-savvy person, that's an insanity because we're using the wrong tools for the job. In the last 4 decades, flying regional with commercial jets got so expensive for airlines in the US, Europe, and Australia that they began stopping service to regional airports. Today, of the 20,000 FAA-approved runways in the US, only 2.5% are currently active. The regional airports left are running at a loss or even going bankrupt, but electric planes could be a fix, and there's already an infrastructure for them. Omer says 11,000 of these 20,000 US runways could support an electric plane, which is a lot cheaper to operate. Alice could save about $800 per flight hour compared to a normal turboprop plane. It's a tenfold increase in the number of potential destinations, all the while not having the significant burdens on the communities of noise and pollution. As for the distant future, electric aviation could come in all kinds of forms. Uber is already working on an electrical vertical takeoff and landing vehicle, or eVTOL, that could pick you up right at your house and fly you to an airport. Even big players like Airbus, Boeing, and Rolls-Royce are betting on this future. We set out on a journey that's akin to crawling, walking, running, leaping. We're now in the phase of walking. The running part will be the bigger electric airplanes flying longer distances, and the big leaps, coming in a decade or so, will be the eVTOL segment, which is vertical takeoff and landing electric-powered machines that effectively take off and land where we want them, bringing the airports to people. Everyone we talked to said that's still about 15 years off, and now that an electric plane has actually proven successful, those in the industry are hopeful that investment into battery development will start rolling in. Because to break out of that infinite power and weight loop we are talking about, we're going to need more efficient batteries for electric planes to really take off. The question is, when does it make economic sense and who has the many billions it will take to bring a product like this to market in 15 years' time? So, is it the future? Absolutely. That's all for today. I hope you liked the video. If you did, make sure to hit that like button and subscribe to the channel so that you never miss any amazing video from us.